cubed minus 2x squared plus 7. Now that we have the shortcut rules, what are they? The main one, there's two functions really well, three I guess, where we always know the derivative. What is the derivative of a constant function? 0, because the graph is a horizontal line, slope would be 0. What's the slope of a linear function, mx plus b? Like we know that, we don't need to use any shortcut rules. That's just, if it's linear, we know the answer. What if it's x to a power? Now we use the power rule. The power rule says anytime we need to find the derivative of x to a power, we know it is this formula, we're done. Those are all the ones where we know the derivative. What were the other rules that were mentioned? Product, quotient, sum, difference, constant multiple, things like that. What do those do? Those say I have some function, like this one. I'm kind of adding up three different things, right? So the sum rule says if I want to find the derivative of these three things added together, I can break it apart into three pieces and find those separately. Did I find the derivative? Going from here to here. This line says I want to find the derivative of all of this. So what does that ddx symbol mean? People ask about Leibniz notation. Really, it shows up now. Any f prime of x says take the derivative of f of x, right? So I always think of this ddx as notation saying I still need to do this. I'm not done yet. When have you found the derivative? When you no longer have a ddx symbol. So like going from this line to this line, there's no more ddx symbols. This is the derivative. Anything after that is just rewriting it to make it look nice. Kind of like, when did you find a limit? Only on the step where you actually plugged in and got a number, right? Before that, you hadn't found the limit yet. You were just rewriting the problem. So when I write something like the sum rule, all it's doing is saying I want to find this whole derivative. Instead, I'm going to look at these three different pieces separately and take those into account. I still have ddx symbols, so I'm not done yet. The only time I'm done is something like the power rule. The power rule says ddx of this is this. No more ddx symbols. All right. So that's where the notation comes in. That's how we break it apart. Most of the rules are just telling us how to go from one step to another step. We still haven't really finished. All we did was rewrite the problem. It's only when you do something like power rule that you really are finishing because you found the full function, the actual derivative. So I break it apart. What happens here? I have like a 2 times x squared, 5 times x cubed. Those don't, the number 2 doesn't depend on x, right? So when I say derivative, when I read this, it says find the derivative with respect to x. ddx is saying find the derivative with respect to x. 2 doesn't depend on x, so I can just move it outside. Alright, so that's the constant multiple rule. Because this doesn't depend on x, I can just move it out. So on here, anywhere I had a constant coefficient in front, I can move it outside. Going from here to here, what's the derivative of 7? I know that's 0. Now I have found the derivative of this piece. I don't need to write ddx or anything anymore. This is the derivative. Then what about these? I hadn't found these yet, so I still need to do this work. This is x to a power. That means I'm allowed to use the power rule. Right, same here, x to a power, I can do the power rule. What does the power rule say? It says move down the power and then subtract 1. So this section is, one, it's a bunch of shortcut rules, but the big idea is I only know 2 derivatives. What's the whole point of all the other rules? Or like, I know the power rule. So every other rule is so that I can eventually use the power rule. The important thing is being very careful with notation. F prime of x is the derivative of that, which is equal to, these equal signs all hold. Right? I don't want to mix up equal signs and have part of it as a derivative, part is the original function. Anything where I'm trying to show work, I just leave ddx as a placeholder. It's kind of like when you kept writing limit, until you plug in, you haven't done it yet. So you're just rewriting something so you know you need to do it later. Right? I have very much encourage getting really organized and using this notation as a placeholder to tell you what work you need to do. And being real careful with your equal signs. Like if you just randomly say f prime of x is equal to this, and you only take the derivative of one of the pieces, and then on the next line take the derivative of the next piece, and you never wrote a TDX symbol anywhere, how do you know when you've taken all the derivatives? Like, how do you know when you finished your work? It becomes unorganized, and it's easy to miss a piece. Okay. So it is one where you want to be a little more careful on writing.
About the derivative of the constant, other than knowing just intuitively that the derivative of the constant is going to be 0, the slope is going to be 0, and is the rule obviously telling us, how do you find that derivative? Won't it be an indeterminate form?
Yes and no. Let's say f of x is equal to c. What happens if I use the limit definition?
You get c minus c over h.
Hopefully y'all wrote this on your back page. That was like 3 points out of 10. Yeah, and I plug in on the top. This is c minus c over h. So I get the limit is h goes to 0 of 0 divided by h. Is h equal to 0, technically? When I write this line, it says limit is h goes to 0. H isn't technically equal to 0 yet, right? H is nearby. What do you get if you do 0 divided by a number that's not 0? Must be 0. So technically, this is the limit as h goes to 0 of the number 0. I haven't plugged in h yet. Whereas it's deceiving, because if I wrote this one, I would say, oh, this is 0 over 0 form. But I can actually simplify it one more line and get rid of that. This is always the number 0, therefore this limit must be 0.
Okay.
That is subtle though. Alright, so we had a bunch of shortcut rules. Power rule's not too bad. I'll try them over here. We have the derivative of x to a power is a power times, or bring the power down, subtract 1. You're going to get great at fractions when you have like powers of 1/2, 3/2, and everything else. You will know how to do a fraction minus 1. It's going to come up over and over. Product rule is this. So leave the first function alone, find the derivative of the second function. And then add the derivative of the first function times the second function. So you just get f of x times g prime of x. You want to use placeholders. F prime of x times g of x. How's this related to constant multiple? Why do I not care when I say this one? Are these two rules consistent with each other? This is a subtle point that's worth saying out loud. There will be multiple ways to solve these problems. You might choose to use the constant multiple rule in a place, or you might write it in terms of the product rule and do more work, or you might set it all up as a quotient rule or some other, or you might rewrite it using algebra first and then only use the power rule. There could be multiple ways to solve a problem. Should that change your answer? We will always get the same derivative, as long as you don't make a mistake. Now, that's a little bit subtle in that if you follow one step versus going a different route, your answers may look different from each other. But you plug in any x value, they would get the same output. So they might look differently, but there's always a way to go from this representation to rewriting it this way, and they're the same thing, based on simplifying or something else. All right? You can go different paths and always get the same answer. What would happen if I used the product rule here? Like I left off this piece from the product rule when I wrote this, right? Technically, I had this first and this second, so if I did the product rule, it should have been this. Why did I not bother writing this piece? What's the derivative of a constant c?
0.
Must be 0. There's no x here. So this is 0 times f of x. I get 0. All of that part goes away, and I only need this. In some sense, we never need the constant multiple rule because we can always do the product rule. But this now looks like more work that you just never need. And the idea is this c doesn't depend on x, I can move it outside. If there's something here that depends on x, I can't just move it to the outside. I have to, if I did, I then have to go over here and correct it. There's more involved. So the product rule says you can't just move one out because it depends on x. You still have to account for that. All right, so let's let f of x equal 3x squared and g of x equal x minus 1. Number 1. What is f of x times g of x? That would equal this function. So number 2. What is the derivative of f of x times g of x? Based on number part 1, I would say this is the derivative of 3x cubed minus 3x squared. Technically, I could say it's the derivative of this. Do I want to use that? Instead, like if I did the derivative of this, I need a product rule, right? We'll do that in a minute. Instead, I could multiply it out and I get this function. Why do I like this one? It's just a power rule, and that's a power rule. I can bring down 3, subtract 1, bring down 2, subtract 1. So I get 9x squared minus 6x. So the derivative of f of x times g of x is this. Right? What's the derivative of f of x? Six x. And what's the derivative of g of x? The number 1. What do I get if I multiply the two derivatives? 6x. Why is that a relevant observation? Or am I just doing random stuff? Maybe when my teacher asked, what am I thinking? That's because I had a teacher that always asked that. I mean, they would ask you a different question, but it's essentially, what am I thinking? Just read my mind, and then he would call somebody by name. I felt like it was me way too many times because I was never convinced the first year for it. But if you go to grad school, it's fun. Everybody knows you. F prime of x times g prime of x is 6x. If I took the derivative, so if I multiply these two together and took the derivative, I got all of this. Why did I say that? This the same thing as take the derivative of f of x and multiply by the derivative of g of x. My product rule says I have to do something else. I can't just take the derivative of one, take the derivative of the other, and multiply. And this is an example that shows that fails. I have f of x times g of x. If I multiply those two together and take the derivative, I get this. I know I didn't make a mistake here, right? Whereas if I just say, what is f prime of x times g prime of x? I now get 6x, which is in no way equal to this. I get the wrong answer. I have to use something like the product rule. Or, well, right now it just says, this is different than that. This is not the same as the product rule. So the last one. What if I do the product rule? So that's what? F of x times the derivative of g of x plus the derivative of f of x times g of x. So I get 6x times 1 plus the derivative that is nowhere here right here. 3x squared times 1 plus my derivative here is 6x times x minus 1. That really what the sentence is. So let's simplify it. 3x squared plus 6x squared minus 6x. This is the same as 9x squared minus 6x. Those two give me the same. So the goal was, can I find the derivative? Hey, here's f and g. If I multiply the two of those together, I get a new function, right? How can I find the derivative of this new function? One option is multiply the two together directly, and then use power rule, so I get this answer. The other option would be, hey, if I'm multiplying two functions, that sounds like a product, why not try the product rule? Look, if I do the product rule, I get the same answer. Anything else is probably not going to work. That's the big thing with this one in the middle. This is the most common one. Just take the derivative of each and multiply. That never works. You lose too much dependence on x. Any questions? So, what if I tell you to find the derivative of this? What is your only option? I guess you have two options. What does that say? Take this and multiply it together 200 times? I can do a lot of product rules. Or I can multiply it all out and I get a polynomial, and then I can do power rule. As of today, that's your only choice, which means we want to assign this in homework. On Friday, we can assign that, you can do it in 2 lines. So there is a way to avoid doing all the work we're doing, and that's going to be the difficult part of this chapter. You will have lots of tools handed to you, knowing when they apply and which is the easiest to use. You could use 3 or 4 different tools, or you could do this one thing first and only use this technique. All right. So that one we will definitely do Friday, not today. So there's one more rule we didn't mention yet, quotient rule. So this one says take the bottom function, multiply by the derivative of the top function, subtract the top function, multiply by the derivative of the bottom function, all divided by the bottom function squared. It is possible to memorize it, I just did it. Remember I took calculus in high school. Apparently I only remember things that I think are stupid. the textbook said, oh, it's easy to memorize the quotient rule. All you have to do is remember this one short saying. Bottom times derivative of the top minus top times derivative of the bottom, all over the bottom squared. That is not a short saying. You took up the entire margin. And way too many years later, I still remember that because I thought that was the dumbest trick to remembering the rule ever. It was such a stupid idea, I couldn't help but memorize it. The one that, you do YouTube, there's songs for it. What's the difference between the quotient rule and the product rule? Let's say you have the product rule memorized. How does it compare to the quotient rule?
You replace multiplications with divisions and replace additions with subtractions.
Yeah, like there, when I write out the product rule, I get a plus sign, right? Which means I can do those in either order. I could find the second piece first and then add the first piece. What's the difference with the quotient rule? I get subtraction.
Yeah, and that is.
So I have to have this first. I have to do f prime first, multiplied by g. Whereas there I'd written it second because it didn't matter. The only difference between those two, this numerator, is a subtraction sign. If you subtract, order matters, right? If you subtract in the wrong order, you get negative the right answer. So order matters. And then what's the end of it? Well, I start with a fraction. I have to divide by something, keep it a fraction. I divide by the bottom part squared. So the other one that we were taught was, if you want to remember this, just remember the word voodoo. So think of your fraction as u divided by v. What comes first? Is v du. If I know that piece is first, I can now hopefully fill out the rest of the formula. What's the next piece? Minus u times derivative of v. And then divide everything by v squared. Just have to remember that part. There's other ways to remember it. So, as an example, f of x equals x plus 3 divided by x squared. If I do the quotient rule, that says, so I want to find the derivative of this. My quotient rule says when I have d dx of a fraction, what do? It would be my second part, the bottom part, x squared, times the derivative of the top, minus the top, times the derivative of the bottom, all divided by the bottom part squared. So I get x squared, derivative of x plus 3, that's a line with slope 1, right? So my derivative is 1. Here I haven't had a derivative yet. All I did was say, instead of looking at the derivative of this, it is the same as doing this by the quotient rule. Which is nice. This isn't x to a power. Okay, I have a line and I have x to a power. I know these. So I rewrote it into things that I know. So now this is the derivative. And if you look at the back of the book, they almost never simplify from there. And it's because you found the derivative. Anything after this is just algebra making it look nice. In chapter 3, we will need to simplify. In chapter 2, it doesn't matter. Because in chapter 3, you're going to set the top equal to 0. If you set the top equal to 0, you probably need to rewrite it so you know what's happening. How else could I have done this? Hey, f of x is actually equal to this. Do I have a quotient anymore? I just have x to the power, so what's the derivative? Negative, bring the negative 1 down, x to the negative 2, plus 3 times negative 2, x to the negative 2 minus 1. So I get negative x to the negative 2, minus 6x to the negative 3. doesn't. That is the derivative. Using only the power rule, did not need the quotient rule. Looks nothing like the other one I found, right? Why is that? The second time I took a quotient and was able to rewrite it as just powers, adding powers together. This one, I left it as a quotient, so my answer is a quotient. They don't look the same, but you can actually show they're equal. You will always have multiple choices on how to proceed. The idea is practice enough so you know kind of which one's the easiest. I always say this is algebra first. Make the problem easier and then do it. If I had something, this is the last comment, like x squared over x plus 3, can I do the same trick? This was nice because I only divided by x squared. So I could break apart my base and make it all nice. Here, I actually can't simplify this, can I? I can't simply rewrite this as x to a power anymore because I have x plus 3 in the bottom. I am stuck with x plus 3 in the bottom. I'm stuck with something in the bottom. What does that mean? No matter what, this is a quotient. So really, if I want to find this derivative, I now need to use the quotient rule. It looks very similar to the other one, but it plays out, I don't have the quotient. I really should use the quotient rule. That's the part of the homework that really, one, you want to get right answers, but two, think about how you can solve this in different ways. Some of the book problems say use 2 or 3 different shortcuts. This is what they're trying to get you to use. All right, I'll see y'all Friday, and Saturday we start 3.4 on Friday.